Okay, today we're going to continue with the square root method, and really what we're going to talk about today is making a decision on how to solve, because now we have two ways to solve a quadratic. We have factoring and we have square root or inverse operations. And so we want to kind of strategically choose which of the two methods we now know are we going to use to solve a given quadratic. So first of all, we cannot use the square root or inverse operation method if I have a variable term in more than one place. So factoring, if I have something that's in standard form, where I have this ax squared plus bx plus c equals 0. That's what I'm going to have, where I have a degree 2 and a degree 1 variable term there. So I have my variable in more than one spot. Then for now, I'm going to stick with factoring. Okay. For my square root or inverse operations, do I have a single variable term, which means it either looks like this, ax squared equals a number, or maybe it looks like this, x minus c squared equals a number. Okay, so I only have a single variable term, and then I can use inverse operations or square roots to solve. So when we do the homework today, you're going to have several different looking quadratics, and some of them you can't use this method to solve. Some you have to factor. For others, maybe you could do both. And then some you can't factor, they're not factorable, and this is going to be the only method we have. So part of what our goal today is just choosing the best method. So when I look at this first quadratic and it says solve the following quadratics, what's the best method to solve? We're going to factor here. And the way that I know that I'm going to factor is because I have both that degree 2 and degree 1 term, or my variable term, in more than one place, and they're not like terms. I'm not going to be able to combine them. So I need to get it set equal to 0 in order to factor. So it's kind of funny because for one method, we got to get everything to one side, get it set equal to 0. For the other method, we're leaving our variable and we're moving everything over. Okay, so kind of two different things that we need to think about and which one works when. So when we're factoring, we get it set equal to 0. And then create our factors, 2x and x, and I want this to OI to be +1, so maybe I'll go 3, 1, +3, -1. I factored, and pretty efficient there. Here are my two solutions for x. Okay. When I look at my second example, I see that I have a single variable term, so I'm going to use square root method or inverse operations. So I'm going to subtract 7 from both sides, because I also don't know if this is factorable right away. I could get it set equal to 0 and I could try to factor this one as well. But I don't know. And so I might as well just go ahead and use inverse operations and see kind of what transpires as I go through here. So subtracting 7, divide by 3, r squared equals 50. So it wouldn't have been factorable because this isn't a perfect square. And then using inverse operations, taking the square root, r equals plus or minus, and 50 simplifies to 5 rad 2. Okay, so best method there was square roots. On number 3, again, this looks like here, where I have that parentheses squared. Now, like we did in the notes yesterday, I could try to factor that by like multiplying that out and then getting it set equal to 0. But best method to start with here is using square root or inverses. So add 6, 3x minus 2 squared equals 36. Square root, 3x minus 2 equals plus or minus 6. Now, because this was a perfect square, I know that this is one that could have also been factored. But this is going to be my most efficient way to get my solutions, is just continuing to use inverse operations. So add 2 over and divide by 3. I like to just get everything. So now I've isolated my variable, right? So now when I get here, because I have a perfect square, I can get two solutions. One would be if I did 2 plus 6 over 3, and the other would be if I had 2 minus 6 over 3. So breaking apart that plus or minus, giving me 8/3 as one solution and -4/3 as my other solution. Okay, so I isolate that variable down, and then when I get here, if I have an integer value, then I'm going to split it apart and solve. Okay, so here, had a perfect square, was able to get my two solutions, again, at the end, breaking it apart and solving. But because we saw that it was a perfect square, we could have also factored this. If I wanted to factor this, if I had done factoring, what that would have meant is taking 3x minus 2 squared minus 6 equals 30. Taking this 3x minus 2 squared and expanding it. So I'd have 9x squared minus 12x plus 4 minus 6 equals 30. So I would have had to multiply this out. Now I got to get it set equal to 0, but first let me clean up. Be minus 2 equals 30. So I'd have 9x squared minus 12x minus 32 equals 0. And then I'd have to factor from there and go -8, +4, giving me -24 and 12, giving me that middle term. And then I get the same answers. Okay, same answers, different method. This is a little more efficient because I don't have to expand things out. But I mean, debatable. Like if you're really good at factoring, that was pretty quick as well. Okay, so two different ways I could have solved that one. On number 4, there's not going to be two different ways. Well, with the two methods we know, the two different ways, because I can't solve using square roots here because I have that degree 2 and a degree 1. I can't combine these variables. I have variable term in more than one place in that equation. So I know that I have to use factoring. And so I have to get it, again, set equal to 0. We can't forget that step. That's going to become 18n squared plus 48n equals 0. And then the way that we would factor this quadratic is by using GCF. So I can take a 6n out here, leaving me with 3n plus 8. And then here are my two factors. So this first factor is going to give me n equals 0. My second factor giving me n equals -8/3. My two solutions. Okay, so as you do the work today, you're going to be deciding, do I need to factor? Because I have more than one variable term and I have to. Or could I use inverse operations instead? And really trying to get comfortable with flipping between two different ways at this point that we know how to solve quadratics. And then our next set of notes, we're actually going to add a third way, the quadratic formula, that allows us to solve quadratic equations a different way as well.